In section 3.4, we're going to talk about the real zeros of polynomials. The fundamental theorem of algebra says that the biggest exponent in a polynomial tells you how many total real and or complex zeros of a polynomial. We're just going to focus on the real zeros. The best way to go about finding the real zeros is to use the graphing calculator. So in example 1, I'm going to find all the rational zeros of p of x equals x cubed minus 3x plus 2. When you graph it, the graph looks something like this. This 0 is clearly at negative 2, and this one is at 1. So the zeros are negative 2 and 1. But the other thing that we're going to talk about doing is factoring polynomials. So in factored form, this polynomial would be x plus 2 and x minus 1 squared. The reason it's x minus 1 squared is because at this 0, the shape of the graph is a parabola, and we called that multiplicity 2, or in other words, the factor is a square. Factor the polynomial p of x equals 2x cubed plus x squared minus 13x plus 6 and find all of its zeros. Well, instead of factoring it first, we're going to find the zeros first. Then we're going to work backwards in order to factor it. So if you graph this on your calculator, you're going to notice that one of the zeros is at negative 3, one of the zeros is at 2, and then the other one is between 0 and 1. If you use the zero function on your calculator, it'll tell you that the 0 is at 1/2. So if those are the zeros, then in factored form it's x plus 3, x minus 2, and then this one, side note, the factor would be x minus 1/2, but we don't like fractions. I get rid of it very quickly by just taking the denominator of the fraction and putting it in front of the x. So this is your factored form of 2x cubed plus x squared minus 13x plus 6. In example 3, we want to let p of x equal x to the 4th minus 5x cubed minus 5x squared plus 23x plus 10. Let's find the zeros of p and sketch the graph of p. Well, the sketching the graph of p, I assume that you can just plug that into your calculator and look at the graph. What I want to do is focus on finding all the solutions. Not all the solutions of a polynomial are rational. That means they're not always integers or repeating or terminating decimals. Sometimes they're irrational numbers. When that's the case, we're going to have to use the quadratic formula in order to find any irrational solutions. Let's see, negative b plus or minus square root of b squared minus 4ac all over 2a. That's the quadratic formula. So what I did was I graphed the original polynomial in my calculator, and I found that two of the solutions are at negative 2 and positive 5. Those are the nice solutions. What we're going to do now is we're going to factor those two zeros out of the original polynomial. It does not matter which 0 you start with. I'm going to start with negative 2 just because I wrote it first. We're going to synthetically divide it out of the original polynomial. So the original polynomial was 1x to the 4th minus 5x cubed minus 5x squared plus 23x plus 10. So we drop the first number, negative 2, add down, multiply, make sure you don't make that negative, add down, multiply, and you get 0. Because negative 2 was a 0 of that polynomial, the remainder should also be 0. Now, I'm not going to write the new the quotient. I'm going to leave this alone, because now I'm going to take the second 0 and I'm going to divide it out of the previous quotient. Now, remember the original polynomial started with x to the 4th, so this one starts with x to the 3rd, just as a reminder. All right, drop the first term, multiply, add, multiply, add, multiply, add. Because the previous quotient started with x cubed, this one starts with x squared. It's x squared minus 2x minus 1. Because it's not factorable, that means that the solutions that come from it are going to be irrational. So we're going to use the quadratic formula to finish solving. So x equals the opposite of b is negative 2, plus or minus the square root of b squared minus 4ac all over 2a. When I simplify this, I like to simplify it in 3 parts. So I get positive 2 plus or minus the square root of over 2. So I get 2 plus or minus 2 square root of 2 over 2, because that's what the square root of 8 simplifies to. And that becomes 1 plus or minus the square root of 2. So those are the other 2 answers. They're just irrational. Remember, the other 2 answers were negative 2 and 5. So my 4 answers to this quadratic function are negative 2, 5, 1 plus the square root of 2, and 1 minus the square root of 2. By the way, all complex solutions come in pairs. The reason that happens is because of the plus or minus symbol in the quadratic formula. There are some mathematical concepts that are outdated now because of the use of the graphing calculator. One of those outdated concepts is something called Descartes' rule of signs. Descartes' rule of signs talks about a way of determining how many positive and negative real zeros a polynomial will have. And it has to do with sign changes within the polynomial. We don't even need to do that. If we want to know the number of positive and negative real zeros, you're just going to graph this in the calculator. When you graph it, you'll notice there are 2 zeros. There's 1 real positive 0, and there's 1 real negative 0. All the other zeros are imaginary. So now we've talked about using the graphing calculator to help us factor a polynomial. I don't care how big the polynomial is. If they ask me to graph or factor it, the first thing I'm going to do is I'm going to graph it. So if you graph 2x to the 5th plus 5x to the 4th minus 8x cubed minus 14x squared plus 6x plus 9, you'll see that it absolutely hits the x-axis at negative 3, at 1, and the, that was a negative 1, sorry. There was a negative 1 and a positive 1. And then there's another one that's between 0 and 1. So, or between, 1 and 2. We have to find that. So if I use my 0 function to find the 0 that's between 1 and 2, it's going to tell me that it's at 1.5, which is 3/2. Now, the one thing I do want you to notice on your graph is that at negative 1, instead of the graph passing through the x-axis, that one bounces off. It looks quadratic. That means it has a multiplicity of 2. So when you factor, you get x plus 3, you get x plus 1 squared, x minus 1, and remember when you graph, or when you put in factored form that 0, you get x minus 3/2, which is the same thing as 2x minus 3. So there's the factored form, and all I had to do was graph it in the calculator, find the real zeros, and just notice if there were any multiplicities. Like I said, we can use a graphing calculator to find the solutions to a polynomial, or the real zeros. Sometimes the zeros, we just want the decimal equivalents. So if we graph 3x to the 4th plus 4x cubed minus 7x squared minus 2x minus 3 equals 0 in the calculator, you'll notice that there are 2 zeros. One of the places that the graph crosses the x-axis is between negative 2 and negative 3. So if you go and use the 0 function, and you use negative 3 as your left bound, negative 2 as your right bound, you'll find out that the 0 is at negative 2.3 rounded to the nearest tenth. The other 0 appears as if it's between 1 and 2. So now if you go use the 0 function on the calculator, 1 is your left bound, 2 is your right bound, you'll find out it's at approximately 1.3. A fuel tank consists of a cylindrical center section. Remember, a cylinder looks something like this. And that's 4 feet long, I should have written that. And there are these 2 hemispherical ends. They're like half circles. If the tank has a volume of 100 cubic feet, what is the radius r of one of the hemispherical ends rounded to the nearest hundredth of a foot? Well, since they gave me the volume, I need to know the formula for the volume of a cylinder, and those 2 hemispherical ends, if you put them together, they're one sphere. So I also need to know the volume of a sphere. The volume of a cylinder is pi r squared h. And the volume of a sphere is 4/3 pi r cubed. Since I know that the volume of the whole tank is 100, the whole tank together would be the sum of those 2 volumes. And the other thing I know from the cylindrical part is I know h is 4. And since I want to solve this for r, I need my equation to equal 0. The reason I want my equation equal to 0 is because I'm going to graph this in my calculator, and I'm going to find where the graph hits the x-axis. That's going to give me the value of r. So when I graph this in my calculator, it hits the x-axis between 2 and 3. So when I use the 0 function to find r, I find out that it's about 2.15 feet.